Okay, so the next question, we want to talk about another graph representation, that is the adjacency matrix. So we are using the same graph again, and then we want to build an adjacency matrix out of the same graph. Okay, so let's come to my drawing board. Hmm? Well, how do I quit? Come on. It doesn't allow me to quit for some reason. Okay, here we go. Okay, so I have already created such a matrix, and then, well, usually, unless we have a certain the self loop, for example, like this one. So if we have a self loop, and then this means that from node 5, we can go to node 5 again. So if this kind of thing happen, and then we are gonna have a 1 here, saying from 5 we can go to 5, and otherwise if we do not have such a self loop, and usually for the diagonal values we are gonna have 0, and this means, well, from 5 we can go to 2, we can go to 6, but from 5 we cannot go to 5, and from 1 we can not go to 1. Okay, so in this case, in most of the diagonal values in this case, well, they are gonna be zeros. Okay, and then, well, we can say from 0 we can go to 1, from 1 we can go to 0, and this means, well, and this will be a 1, and this will be a 1 as well. And from 1 can we go to 2, and the answer is no. So 1 we cannot go to 2, and the same thing, from the 2 we cannot go to 1, so this one will also be a 0. Okay, so once you have done a few lines and a few columns, you will find that, well, this matrix is this matrix, for the values here and here, for the values here and here, well, if we just flip and the x and y coordinates, they are going to have the same value. And the reason is this is an undirected graph. So, well, in this case, we only have to fill half of the matrix, and that will be enough. So how about we make some changes? Say if we make this graph a directed graph, and then the story will be different. Say, for example, well, I'm adding the arrows to all the edges, and now this graph will be a different one. Okay, so for this kind of the graph, and then we can only go from one way to the other, and now all the values will be different. So I have to erase those values, and then I have to do them again. So give me 1 second. Let me erase those values. Okay, so in this case, and we can see from 1 we can still go from 0 we can still go to 1. So let's say for the y-axis, they are the from, and then here I have the 2's. So this means, well, for this cell, this is from 1, can we go to 0? The answer is no. But here, well, we are answering from 0, can we go to 1? The answer is yes. So now, well, this will be a 0, and now we have a 1 here. Okay, and then for some of the directed graph, and we may have some of the edges like this. So for example, 0 we can go to 3, and 3 we can go to 0. So in this case, 0 from 3 we can go to 0, and from 0, oops, well, my bad. It should be a 1 here. So in this case, so from 3 we say we can go to 0, and then from 0 we can go to 3 as well. Okay, and then from 0, where can we go to? We can only go to 1. We can only go to 1 and 7, and then for rest of the values, they will be all zeros. Okay, so this will be another type of the graph representation. It is called adjacency matrix. Okay, so that's it for this video, and I will see you in the next one.